Hello and welcome to another episode of TWiML Talk, the podcast where I interview interesting people doing interesting things in machine learning and artificial intelligence. I'm your host, Sam Charrington. Before we dive into today's show, just a few quick meetup-related announcements. First, let me say thanks to everyone who participated in this weekend's Fast AI Deep Learning course study group. We had a great discussion about Lesson 1. If you missed it, the recap will be posted later this week, so be sure to subscribe to our YouTube channel or follow @TWiMLAI on Twitter for updates. Also, this is your final reminder that the next TWiML online meetup will be tomorrow, Tuesday, June 12th at 5 p.m. U.S. Pacific Time. Kelvin Ross will be reviewing the paper Cardiologist-Level Arrhythmia Detection with Convolutional Neural Networks, which is work by researchers in Andrew Ng's lab at Stanford. For more information, visit twimlai.com/meetup. In this episode, I'm joined by Romer Rosales, Director of AI at LinkedIn. We begin with a discussion of graphical models and approximate probability inference, and he helps me make an important connection in the way I think about that topic. We then review some of the applications of machine learning at LinkedIn and how what Romer calls their holistic approach guides the evolution of machine learning projects at the company. This leads us into a really interesting discussion about problem formulation and selecting the right objective function for a given problem. We then talk through some of the tools LinkedIn has built to scale their data science efforts, including large-scale constrained optimization solvers, online hyperparameter optimization, and more. This was a really fun conversation that I'm sure you'll enjoy. Let's go. All right, everyone. I am on the line with Romer Rosales, who is Director of Artificial Intelligence at LinkedIn. Romer, welcome to This Week in Machine Learning and AI.
Thank you, Sam. How are you? Glad to be here. Really excited to talk a little bit more about AI with you. And I'm really a listener of your show in the past, and I really enjoy them. So looking forward to this.
Awesome. That's great to hear. And I am doing great. And I'm excited to dig into our conversation, which as a listener, you know that I'll start by asking you how you got into artificial intelligence. Tell us a little bit about your background.
Okay. Yeah. So I guess my background as an undergraduate student is on something that is called informatics or informatics engineering. And this is a term that is not used here in the States because I study in Venezuela for my undergrad. And that's kind of like a combination of math, computer science, and stats or operations research. And, you know, looking back 20 years ago, this is exactly what you need to get into machine learning, right? So I was really interested in these topics from very long ago. And once I got into graduate school, I tried to explore those more and more. First, studying computer vision, which was kind of like my first subject area in graduate school. And then realizing that you could do a lot more in computer vision with the right sort of machine intelligence, right? And that got me more and more interested in AI. For example, I was looking at things like how do you recover the 3D structure of an object? And of course, the first thing you do in computer vision is you go into the 3D geometry and all of these things related to epipolar geometry or recovering the camera parameters. But then I tried to approach the same type of problems using machine learning, and it just felt much more natural to me. And then I kept going in that direction and exploring a little bit more of in-depth machine learning. Did a couple of postdocs in the area, one in what I call image analysis, and another one more related to how we scale inference in systems that are so large or so complicated that you cannot really do exact inference, but you have to go into approximate inference. So the area is really called approximate inference in graphical models. So that area really reinforced more and more, what I really wanted to do in machine learning, which is to deal with these very large problems, large systems. And even if you cannot come up with a exact solution to all of these problems, to come up with good approximations. So after that, I went and went into industry, and I started working in the area of healthcare. So, which it's a great area. It's a very, very meaningful area, which really needs. You see a lot of applications of artificial intelligence in this area. I spent about 5 or 6 years in the area of healthcare, and then I moved to Silicon Valley, and right now I am here at LinkedIn. I think I'm very happy, and I think I have been lucky to work on 2 areas that I consider that are pretty useful in general for the socially. One is healthcare, and the other one is my work here at LinkedIn, which is, as you know, deals with the subject of creating economic opportunity for everyone.
Awesome. Well, I am curious about the work that you mentioned on approximate inference. Is that model specific?
Yeah. So approximate inference in graphical models is this area of machine learning where you know that if you really want to compute a posterior distribution, what we call, for a given random variable, given all the information that you know about the system around this random variable. Let's say you have a system of 100 random variables, and you know a lot about 99 variables, but you want to know what those 99 variables tell you about this one variable, right? How do you compute the distribution over that random variable, right? So, for example, everything about the state of a patient, right? The result of many tests. How you can calculate the probability that this patient has a particular disease, for example, right? So we know that in complicated systems, depending on how these variables interact with each other, you can easily go into the field of such large computations that you cannot really compute this, even if you have very large computational resources. And you have to go and explore areas of approximations, right? Of this posterior distribution. So basically, approximate probabilistic inference is the field of trying to come up with the best possible approximations to these very large problems that you cannot solve because they are either too large or simply because you don't have the time to wait for an answer. So anyway, that's in general what this area is, and you'll be surprised how quickly you go into these intractable models. For example, you have random variables that can take 10 values, and you have maybe 50 of those, right? The number of possible states that the system could be in is already quite large. It approximates, I guess, the number of particles in the universe, right? So
wow.
This is why you need this type of approximate algorithms, and they're actually very useful for a lot of the things we do.
Is the common theme between the work you've done in healthcare and the work you're doing at LinkedIn this notion of graphical models? Do you use graphical models much at LinkedIn?
Thinking in terms of graphical models is to me has been a really great way to think in terms of probability. A general way to think in terms of probability. And if you're in the field of machine learning, I think thinking in terms of probability it's extremely useful. And even though you can do a lot of things maybe without thinking directly in terms of probabilities, I think for most of the things that I have done in the past, the notion of probability, probability distribution, approximations have played a very important role. So I think of graphical models as an excellent way to think in general about probability distributions and useful in many areas. In the healthcare field, for example, every time that you need to think about, what is the probability that this particular patient has this disease, given that we know the result of this test and this test and this other test, it is core to everything we do, right? In the same way, in a large internet company like LinkedIn, understanding what is the probability that this member is going to really find value in this information that we are providing to him via the application, right, is core to a lot of the things we do, right? So we want to, at the end of the day, maximize the value that this member gets from interacting with LinkedIn, and encoding this in terms of probabilities, right? Probability that the member is going to engage with this post, or the probability that the member is going to invite a colleague to join LinkedIn, or the probability that this member is going to maybe disable this notification because this notification wasn't the appropriate one to send, is something that we consider every day at my work. So yes, I mean, thinking in terms of probabilities is at the core of everything we do. Graphical models provide a language to speaking in terms of probability that is very general, and this is why I find it really useful. And I was lucky to explore this field back when I was in academia, and turns out that I use it every day basically.
It's really interesting. I've done a number of interviews on the topic of graphical models, and I've tended to think of them in the context of either computational graphs or like graph databases, things like that, and always think of them visually. And it wasn't really until until I heard your description that it really clicked for me that the graph we're really talking about is an application of Bayes' rule and conditional probabilities, and that's really what the relationships are between these nodes in the graph. Is that the right way to think about this?
You hit right on target. Basically, approximate inference in graphical models is a way to efficiently apply Bayes' rule. That is what this reduces to, really. Right? So yeah, for example, algorithms like belief propagation, right? In a graph, right, is an exact way to apply Bayes' rule, right? In some cases, you cannot apply the Bayes' rule exactly, right? Because the computation is too large, and the belief propagation algorithm becomes intractable, right? The exact one, and approximating what belief propagation should do is basically core part of these algorithms for doing approximate inference in graphical models. So yeah, I think that that's another way to put it, right? So inference equates in these probabilistic systems as applying Bayes' rule, and when you cannot apply Bayes' rule, you have to go into approximations, right? So now that is not to say there is a large field of machine learning that maybe you don't have to think directly in terms of probability, right? And for example, I'll argue that even though it is useful, in many cases, thinking of when you need to use a neural network, let's say, to address a classification task, you may or may not think in terms of probability and will be fine with it, right? But introducing probability in the thinking, in the reasoning about how machine learning works is super useful, and it's a great tool, right? Even if you are using neural networks or any other things that on the surface don't require you to think in terms of probability directly, right? So, for example, you have a neural network trained to predict. Let me use the same example in healthcare. You want to predict whether the patient is healthy or not. You can use as input the result of all the tests that you apply to this patient, and the output is going to be an activation of this normally referred to as a neuron in the neural network that tells you whether the patient is sick or is not, right, based on what it has learned from the past. And so far, I haven't brought up the term probability, but if you start thinking about how the activation of the neurons, right, relate to how certain the system is that the patient is sick or not, then you can translate that to a more probabilistic concept and start doing additional analysis on, let's say, how reliable the neural network is, or how much it captures the true relationship between the inputs and outputs, right? So anyway, that is kind of like my summary of why thinking in terms of probabilities is to me is always helpful, even if you are not dealing with them directly, like in some versions of neural networks.
Yeah, I'm really glad we went down this path. I don't, it seems so obvious in hindsight, but that way of thinking about graphical models is going to be helpful for me, I think. Maybe let's jump over to LinkedIn and what you're up to at LinkedIn. Can you talk a little bit about why AI at LinkedIn? I mean, some of that is going to be obvious, but maybe give us a lay of the land of how LinkedIn thinks about artificial intelligence and machine learning.
So basically, in everything you see on the LinkedIn app has, to a large extent, some form of machine learning in the background, right? Let's start from the things that you normally see when you open the LinkedIn app. Let's say the feed, right? The first thing you see normally is the LinkedIn feed, which ranks the conversations or updates or information that in general we believe is the most relevant to you. So the reason why we rank things in that way is because of the how you have interacted with the LinkedIn application in the past, right? So we try to understand what interests you, what is relevant, right? You have a limited amount of time to invest on using the LinkedIn app. We want to make sure that that's the most relevant that we can show you. In the same way, connection recommendations, right? Who would you like to connect to? We try to infer from past activities and your past connections, who would you be interested to connect with? Follows recommendation. Who would you like to follow? What topics you like to follow? How to make messaging interactions simpler, right? How to what to notify you of, right? So we know that notifications, too many notifications could be negative because we don't want to overwhelm anybody by sending too many notifications all the time. But so we want to really, really choose what is the best possible use of your time if we were to send you a notification. So machine learning plays a role there in trying to decide what notification from all the notifications that we could send you has the highest chance of providing value to you. And even in other areas that are not directly consumer or member focused, we use artificial intelligence a lot. For example, preventing some forms of abuse to the site, right? That's another area that understanding the patterns in the past that we have seen of abuse, let's say, to the site, I think we can prevent future problems with it, right? So jobs recommendations, right? So how to connect you with the right job, with the right company, requires of understanding, your skills, how they relate to certain types of jobs. What is your job title? So what type of jobs probably makes the most sense for us to recommend to you, and things like that. In addition to that, maybe your job requires you to know or to learn certain subject areas. So we can also recommend to you learning courses that you can also find in LinkedIn that will maximize the chances of you getting that next job, for example. In the same way, in our search results, when you search for a particular topic or member or product or company in the app, we use artificial intelligence to show you what are the most likely matches to what you are intending to identify in the app. So, I could talk about all of these subjects for hours, right? But it's basically everywhere, yeah.
I'm curious, a lot of what you've described sounds common across internet companies and social types of applications, feeds, recommendations, things like that. I'm curious where LinkedIn's requirements and use cases might be different from some other companies in ways that are interesting.
There are going to be things that are probably in common with other companies and things that are special to LinkedIn. One of the main things that we truly care at LinkedIn is the notion of are we providing the most possible value, right? The highest possible value to the member by showing the member a particular recommendation, for example, right? So we think about this whole interaction with the application in a holistic way, and I think that's pretty interesting. I'm not too familiar with other industries or companies thinking this holistically, right? So, and what do I mean by that, right? So, for example, recently, or maybe a couple of years ago, not so recently, we received a lot of feedback that maybe LinkedIn was sending too much email, right, to people, right, and some of this feedback was public, and that we have acknowledged this. So what we started thinking, well, what we need to do something about this, right, and why is it that we're sending so much email, and if you think short term, right, well, the more messages you send, the more email you send in this case, the higher the chances of engagement, right? So if you want to maximize engagement, sure, at least in the short term, send more email, right? And well, that is a very short-sighted strategy, right? So instead, what if you start thinking about if you want to improve the overall ecosystem of LinkedIn, right? And at the same time, the overall value that the member gets from using LinkedIn. Then you start thinking much differently, right? And one of the early projects that we did in this area was, engagement, as a proxy for value is interesting, but we should also take into account negative signals. Like, for example, is the member disabling or marking the email as spam, for example, right? So let's pick one email type and let's try to change the problem from trying to maximize engagement to a constraint optimization problem where we think a little bit more holistically and say, well, let's try to maximize some form of engagement, which is a proxy to value, subject to some constraints on, let's say, negative feedback, like marking the email as spam. And that turns out, that's that relatively simple optimization problem. Only one email type, two utilities. One is related to engagement, one is related to negative feedback. Had a huge impact on that particular type of notification or email that we were sending, right? And
how do you characterize that impact?
So the way that we characterize this impact is how much negative feedback are we reducing? Right? So how much of a reduction of negative feedback we can measure, right? Mm-hmm. How many fewer emails we can send at what level of engagement? So it turns out that we could reduce the number of emails notifications that we send by a pretty large amount. I think for that initial test that we run, it was at least 40% of email reduction with an equivalent percentage of negative feedback. And the engagement, the proxy to engagement that we were using at the time, which were sessions, right, were almost unchanged, maybe negative 0.5 reduction in sessions. So that's a great trade-off to make, right? So we provide a much better experience at a very similar level of engagement, and we actually could measure that there is a reduction in the negative feedback that we were getting, right? So thinking holistically basically gave us so many more insights into how we can do this across LinkedIn. So we didn't stop here. We said, well, this is great. So it may sound crazy, but what if we do this across all notifications that we're sending? And at the time we were sending the primary form of notification that we were sending were emails. So let's say that we now instead of just why stop it at one email type? Let's across all the possible emails that LinkedIn could send you, what if we apply a similar way of thinking? Right? And then you run into scalability problems and having to work with an entire set of product managers within the company. And how do you deal with that, right? So, and this experience really gave us a lot of insights about how we approach future problems, right? But what we did basically was let's formulate the problem again as a constraint optimization problem, where you are let's minimize the amount of messages that we send. Let's say that we want to really, if we don't have to send any messages and provide the same amount of value to the members, then why not do that, right? So the way that we formulated the problem was, well, let's minimize the number of messages that we send, in this case, emails, subject to a maximum amount of negative feedback that we're willing to tolerate. We want, less than 2% of negative feedback or 0.2% of negative feedback. And let's also make sure that there is certain level of engagement. So we don't want to reduce the engagement too much, because that's our proxy for member value, right? So let's place a constraint on the member value that we believe we are providing, right? And since we have maybe 20 different products or 30 different products across LinkedIn that are all sending some form of email or notification, let's make sure that we don't decrease the engagement that we are directing to those products more than a percentage, right? And then you see how we keep increasing the complexity of the problems and the number of constraints, right? So this turned out to be a project that we decided to do, and which enormously reduced the amount of emails that we send to our members. All the product partners were positive about the impact that this was having across the product, and basically it addressed this very critical problem that we really wanted to solve, which is provide better member value while at the same time reducing the amount of notifications that we were sending, right? So I believe that at the time the reduction of total messages sent to members was close to 65%, or close to 50% overall, with a decreasing in negative feedback of 65% and less than 1% reduction in sessions overall, right? Wow. But we believe this is the right thing to do, and we did it, right? This, even though this came at some cost, which is 1% reduction in sessions, that in a large company that may be a large cost, but it was the right thing to do, and it opened the door to a lot of other things, that a lot of our future thinking about how to approach these problems.
This is a really, really interesting story, a great story, and really timely for me. I was just giving a talk earlier this week and talked about how the metric that you choose to optimize around, has a huge impact in the way you can approach a machine learning problem, even if it's fundamentally the same kind of problem. A recommendation problem, you could look at it from the perspective of revenue or profit or lifetime customer value. And there are all kinds of choices to make there that have different implications on the ultimate performance of your models, but also the user experience, the customer experience. So it's really interesting to hear how you've applied this. Are there other areas outside of this email domain that you've applied this kind of holistic thinking to?
Yeah, so we're now using this to other types of notifications as well. But I think one interesting example is also in the area of forming connections, right? So in LinkedIn, we have this product called PYNK, or People You May Know. And this product is basically powered by machine learning algorithm that determines for a particular person what are the connections that in the past, we used to think about what are the connections that are most likely to respond, yes, I want to connect with you, right? And when you then rethink the problem and think, well, maybe we should think about the problem in terms of what are the most valuable connections, right? Or what are the connections that will, in the future, you think of value as how much interaction you will have with these connections. Then you start thinking about different objective functions and different ways to provide what we think is a better value to the members, right? So what we started to do was to, instead of creating connections after connections, trying to maximize the number of connections that a person creates. Try to maximize the valuable connections, or the connections the connections that matter, right, or that we think that matter, right? So so we reformulated the problem into, let's maximize the chances that you're going to really engage with this person if you connect with the person, subject to some constraints on, I want you to be connected, right? I don't want the members to be severely underconnected because we are too picky about the type of connection we are recommending to this member, right?
Mm-hmm.
So this had a interesting impact on, well, the new connections that you're making are actually, you're actually interacting more with them because of this new recommendation algorithm, and it's probably of higher value to you, right? So as another example where we were thinking about maybe the more of the ecosystem value, or long-term value to the member, right? And another example is in the area of, so for example, on the feed, right, which is a core part of LinkedIn. We want to make sure that everybody in the feed feels heard, right? So when I post something in the feed, I want to make sure that people can see what I posted, and I get feedback, right? If you want to maximize click-through rate, which is the usual metric that you will first think about, you will normally promote members that are very, very popular and get a lot of clicks, right? So, but you want to create a better sense of a community, and people. You want people to feel that they are heard, right? You want to also take into account that maybe some members that are less active, right, will deserve the chance to get feedback as well, right? So we want to maximize overall engagement, not just the gain of a few members, right? While other members feel that they are not heard, right? So that's another area. So what we did is we basically focus on a group of members that are new sharers or not very common sharers or contributors, and decided to make a trade-off. Basically, we want to have we want to have most members receiving feedback as compared to just a few members receiving a lot of feedback. And again, this had a very positive effect on the members who contributed, and they were not necessarily the most popular members or heavy contributors, but because of the feedback they got, there was a considerable increase in how much these members contribute again and share another article or share their views again on the site. And again, this is something that maybe it is obvious once you think about it, but it is not how usually most companies start when they want to optimize something like the feed, for example, or connection recommendations. Usually, the tendency is to optimize for the metric that you can see the most now,
right,
and hope that that is the metric that in the long term is going to be the best metric to optimize. Right. And we have realized that that's not the case in many instances. And instead, you need to think a little bit more holistically and come up with a better proxy of what is the metric that is better for the overall good of the member and the engagement overall in the site. Now, this is not to say that we have solved the problem of what is the best long-term metric that you should optimize for. I think that's a really difficult problem, and in many cases, you get counterintuitive results into, I want to optimize how much daily active users there are in the site in 1 year, right? What should I optimize more in the short term in order to get there? And I think that's a toughest question. That's a tougher question, right? But basically, this is reflects our idea that you should try to optimize whatever is closer to the long-term metric you want to see change, as long as you have a way to more or less approximate that metric with something that you can measure in the short term, right? Because if we wanted to apply this idea, I would like to optimize the feed, let's say, or LinkedIn overall for a metric that says how many people in the global workforce are employed and believe that have economic opportunity, right? But what is if that's my objective function? What
It can
is
get pretty broad.
Yeah, what is the derivative of that with respect to the variables that I can control? That is a problem. So that is trying to fill in the intermediate proxy objective functions that you think will get you to that overall ideal, right? Is where there is so much interesting work and ideas in machine learning that this is why this is such a broad subject, right? And but this is more or less how we want to think about it. What is the true metric that you really want to go towards, right?
So now that you have this experience, do you find that teams are starting with more holistic models from the beginning of a modeling process, like for new features? Or do you find that it needs to be more of a crawl, walk, run, and they should still start simple and evolve and mature over time?
Yeah, so I think that definitely I always go for try the simplest thing first, right? And try to understand from the simple approaches first, right? And for a new company that needs to grow very fast, right? In order to get that engagement going, especially let's say you're starting a new application for which the social aspect is very important. Perhaps trying to maximize the number of connections as much as possible is the best, right?
Work on the cake and not the icing or the cherry.
Exactly, right? So now, once you start learning and realizing that, hey, maybe our members have a limited amount of time and energy and attention, what is the next best thing that we could do to provide that value to them, right? Then you probably start thinking into more sophisticated way to optimize for that. Also, at the same time, when you are early, when a company is in the early stages, you probably don't have a very large investment in machine learning, so you need to try simple things first, right? Because the ROI is largest, right, at that stage, right? But once you have understood a lot about the members or people who use your application, it's really it turns into an ethical question. What is the best thing that we could do for our members, given that we have this level of maturity in understanding how to bring value, right? And this is what we are trying to do, right? We try to do the best we can, given all that we have learned throughout the many years at LinkedIn.
There are certainly implicit, if not explicit, tones to fairness implications of some of the things that you described, like particularly around the feed and what goes into the feed and that kind of thing.
Yeah, exactly. I think that's something that we always keep in mind. I think that we always try to think about all of these considerations in terms of fairness, reducing bias and members' privacy, of course, right? That go into all the things we do. But as long as all of those aspects are satisfied, the thinking about how to think holistically to provide the best possible value, right, to the members is something that is now reflected in many of the things we do. So, and I guess it helps that my team is responsible for a lot of the products that I mentioned earlier. So we really try to make sure that this way of thinking permeates across the organization and start at that level instead of thinking too narrowly or too greedily in terms of maximizing one particular metric at the expense of other things that we may be missing, right? That can be better for the overall ecosystem, right? So anyway, so that's just wanted to summarize a little bit how it is that we're thinking about all of these problems at a high level, and maybe provide a few examples like the email example where we could touch a little bit at the low level.
Yeah, absolutely. I'm curious as your team takes on more of these constraint optimization types of problems. Has it changed, or to what degree has it changed the tools that you use, the data pipelines, the modeling process, the general approach to rolling these out?
Okay. Yeah, that's a good question because we had to build tools for doing this more efficiently, right? And some of the tools, for example, are that we had to build are these large-scale constraint optimization solvers, right? That can take advantage of some level of distributed processing, right? And provide a result to the problem very quickly, right? Because a lot of these problems, really, what something that is common about all of these problems is that you're normally um, computing a trade-off across many different objectives. For example, number of negative feedback that you get, number of sessions that we see, perhaps sessions to a particular product, and so on, right? Number of connections that you make. So what is common across all of these kind of applications or examples that I've given is that you always end up with how do you set the right trade-off across all of these possible objectives, right? So in optimization, I think that's what's normally referred as the Pareto curve, right? What is the right point in the frontier where you want to operate, right? So in 2 dimensions, this is just a curve and two variables, and usually an increase in the return that you get in one variable implies that maybe you will get a negative impact on the other variable, right? So and that's a very large set of combinations of variables that you could get, right? In 2 dimensions. What if you have three different objectives, or we call it utilities, three different utilities that you need to balance, or four utilities? How do you quickly solve these problems? Now, one thing you could do is that you could solve these problems offline, right? And wait for your quadratic programming or linear programming solver to give you the solution, and then put the solution into the system, and and measure, just to make sure that things are going the way you expect. So that's one way to deal with the problem, and we continue to build ways to scale these constraint optimization problems in our systems. Another way that you could think of these problems is, let's say I try to do this online, right? And this is an interesting problem that we're working on these days. Let's say we have three utilities, right? And I want to learn what is the best combination of those utilities that satisfy my constraints as I serve the traffic, so that I can adjust these things as the traffic is being served, right? So there are working on online, we call it online model selection methods that allow you to, a member comes, we serve this with a particular combination of parameters, and we determine, how well the response to that combination of parameters was, and then the system automatically says, based on all the information that I have collected in the past about how members are interacting given this parameter setting, what is the next best set of parameter settings that I could try to improve my utilities and still satisfy the constraints, right? So there are actually ways that we are trying to adjust or solve this optimization problem where you have a few, we call it hyperparameters, right? That determine how much importance each of the utilities has, right? And the process of trying to adjust this in real time as we see more and more data is one of the areas that I think is very exciting, and we have seen quite a few positive results in this direction. Of course, this method may not be able to scale for very large dimensions where you probably will need to solve a full offline constraint optimization problem, but in many practical situations, being able to do this parameter tuning in an online form seems possible, and I think this is one of the areas where I think we're very excited to see positive results these days. So
So in this context of an online system, you mentioned the dynamic model selection, which makes me think of, not so much updating hyperparameters or parameters in real time, but you have offline developed as opposed to one single model, multiple models, and you're trying to fit a given user to a model online and then use that model. But it sounds like you're doing a bit of both. I guess I'm trying to get some confirmation. Am I hearing right that there are two different types of things at work as you're trying to make the system more dynamic?
Yeah, I think the two examples you provide are very related problems, right?
Okay.
I was, and I think one could approach them in a very similar way. I was referring mostly about the problem of fitting hyperparameters, right?
Okay.
Which is basically when you have a linear combination of utilities, you have that hyperparameter that specifies how much of each utility, what is the weight for each utility, right? And how you should change that weight to satisfy your constraints and to at the same time maximize an objective, right? So adjusting those parameters in real time is what mostly I was referring to. Right?
Got it.
However, that is you are right on target when you relate this with the other problem of trying to decide in real time what is the best model variant, right? That you could use instead of having to run different A/B tests separately. You may want to run just one A/B test and let the A/B test itself auto-tune it, right? Self-tune it, right?
Mm-hmm.
So that you can decide what is the best model variant. And those two problems are very related, and we are exploring these directions as well.
Just in terms of a time check, we've had a really interesting conversation so far. Are there other things that you would add in and around this topic of trying to approximate more holistic metrics in the way we model?
No, I think that reflects at a high level. I think how we're thinking about it. There are some papers that I can also share with you offline that go into more details about this. We have a pretty active group of scientists, engineers, analysts that publish papers and attend conferences, are pretty active in the research community. And we have the data website at LinkedIn. You can search for a few blog posts and articles that we normally publish there to go into a lot more detail into what I just said. We're pretty active overall in the research community, and something that I found, I guess that I think is also probably interesting to mention here is that I spent a lot of times, many years in academia, right? And I actually did several postdocs, and was very interested in core research in this area. But working in industry, you never run out of problems that there is no answer for, and or that the answers are just not that great when you try them, right? That this creates a constant influx of problems that you wish you have more time to solve, that are pretty advanced or research driven problems that you could publish and make a lot of impact on. So I found the working in industry as one of the main sources of interesting problems that I can think of, for publishing or for just personal satisfaction of being able to approach the problem for a greater good, right? So I think that that's one message that I also wanted to share, because it took me some time to realize this, but once I realized it, this seems so obvious, right? So this is such a great place to think of, to realize what are the really important problems that matter, and if you solve them now, it will have a big impact not only on just core research, but also on the impact that you can have to society in general, right?
Right.
So I think I find it a great place to do that, and LinkedIn has different initiatives also with academia. For example, we run this what we call the Economic Graph Research Program, right? Which is another way for us to share. Hey, here is data that has been, of course, properly de-identified, and this information has been properly processed to be shared with certain group of people, right? And we work together with professors or people from academia and other parts of outside of LinkedIn to be able to share, hey, this is the data, these are problems we have. What are other problems that you see that for which you can use this data and actually, through research, make a positive impact, right? So just wanted to mention that as well as one of the things that I'm pretty excited about, what LinkedIn does overall. And if anybody's interested, I think this is something that you can check out also in our web pages.
Okay, great. Well, we will include links to those sites in our show notes, as well as any papers that you want to send over. But Romer, thank you so much for taking the time. It was really a pleasure to chat with you.
Thank you very much. It's my pleasure. Talk to you later, Sam.
All right, everyone. That's our show for today. For more information on Romer or any of the topics covered in this episode, head on over to twimlai.com/talk/149. For the details of our upcoming meetup or the Fast AI study group we formed, visit twimlai.com/meetup. As always, thanks so much for listening and catch you next time.